Hey everyone, and welcome to this explainer. Today, we're diving into a massive shift in how we actually build applications with large language models. We're going to explore how you can transition from messy, hard-coded text strings to building really robust, type-safe LLM applications using Python templates. If you've been working with AI lately and feeling like your code is just, getting totally out of hand, well, you're in exactly the right place.
Okay, let's just get right to the elephant in the room. Are your LLM outputs unpredictable? Because if you are still dumping massive, hard-coded strings into your app to talk to an LLM, you are practically begging for unpredictable garbage. When we treat prompts just like basic autocomplete inputs, we're leaving our apps completely vulnerable to context collapse, prompt injection, and wild out-of-nowhere hallucinations.
So here is our roadmap for sorting this out today. First, moving beyond hard-coded strings. Second, the 3 chat roles. Third, Python prompt template classes. Fourth, ensuring strict type safety. And fifth, scaling production AI pipelines.
All right, let's jump right into Section 1, Beyond Hard-Coded Strings, and how we can escape the raw text anti-pattern.
Think about it. Before you build a house, you need a blueprint, right? Well, that is exactly what a prompt template is. It's a dynamic, reusable component that replaces static, rigid text. By using placeholders, those little bracketed variables that get filled in at runtime, you completely separate your core application logic from the raw text. This makes your prompts super consistent, and over time, it drastically improves your results by taking the randomization out of how your prompts are actually written.
Because honestly, without templates, embedding raw prompts directly into your code is kind of like pouring concrete everywhere without putting up a wooden frame first. It's just a mess. The research clearly shows that processing prompt text as a single, continuous string frequently leads to instruction drift, rapid context collapse, and makes your app highly susceptible to prompt injection.
Moving on to Section 2, the 3 chat roles, or what's known as the tripartite role architecture. The shift from basic autocomplete to modern chat-tuned models means that execution priority is strictly divided into 3 formal roles: the system, the user, and the assistant. This tripartite role architecture isn't just some cosmetic formatting trick. It establishes a formal hierarchy of execution priority that perfectly matches how these models were actually trained in the lab.
You can kind of think of the system role as your AI's HR constraints or its strict job description. It sets the overarching persona, the required expertise level, and the boundaries. Because this acts as a high-level briefing, the model prioritizes these instructions as absolute foundational rules. It establishes the baseline conditions that all your tasks will execute on, way before any user input is even looked at.
Then you have the assistant role, which is absolutely crucial for multi-turn conversations. Funnily enough, if you didn't give older LLMs this explicit assistant tag, they would literally hallucinate their own user inputs or just blindly repeat formatting prompts. Explicitly tagging past agent outputs simulates successful turn-taking. It allows the model to clearly distinguish its own historical reasoning from what the human just said.
Okay, Section 3, Python prompt template classes. Let's look at how we actually build these blueprints in code.
So, the crucial difference here really lies in the tool you use. A standard prompt template is totally fine for formatting text in older, single-string completion tasks. But a chat prompt template, that takes it so much further. It assembles an entire structured, role-aware conversation. It lets you combine system instructions with user questions, ensuring that every single role is properly formatted before it's ever sent off to the API.
Think of this as your code's assembly line. First, you define your placeholders, like, say, asking, how many Earths fit inside that specific planet? Next, you inject your dynamic context using a .format method to replace that placeholder with, let's say, Jupiter. Then, the template automatically structures this into properly tagged chat messages, and finally, you can confidently invoke your model. It's modular, it's reusable, and man, it's just so much cleaner than raw strings.
Which brings us to Section 4, ensuring strict type safety. It is time to move past untyped dictionaries.
Seriously, if you're just passing untyped dictionaries around in a production environment, you are playing with fire. A single typo in a variable name, or passing an integer when a string was expected, can literally collapse your entire pipeline at runtime. Standard libraries often leave these inputs completely unvalidated until it's way too late, which causes severe prompt degradation or just outright API rejections.
As software engineers, we've got to remember this core principle. Embedding raw prompts directly into application code represents a significant anti-pattern that violates the separation of concerns. By decoupling your architecture, you improve version control, you prevent prompt injection, and you make your entire system significantly more reusable across different functions.
So to achieve true type safety, modern architectures lean heavily on validation schemas. By compiling templates directly against a Pydantic schema, using tools like Pydantic handlebars, you enforce really strict rules. The compiler statically analyzes the template, and if there's a typo or a missing field, boom, it fails immediately at compile time. This guarantees your payload is perfectly JSON safe before you ever spend a single API token.
Finally, Section 5, Scaling Production AI Pipelines, where we'll look at programmatic optimization and DSPy.
Frameworks like DSPy take all of this to an entirely new level. Instead of manually tweaking prompt templates through endless trial and error, DSPy treats prompts as programmatically optimizable modules. You define what a model must do using declarative signatures like, say, context plus question equals answer, rather than hard-coding exactly how to prompt it. Under the hood, DSPy uses optimizers to automatically refine instructions and few-shot examples. It finds the absolute best prompts systematically, rather than relying on our human guesswork.
So as we wrap up this explainer, I want you to ask yourself a really critical question about your own code base. Are your AI pipelines built on solid code, or are they just a messy string of words? Are you still relying on fragile hand-typed strings, or are you ready to upgrade? By utilizing strict chat roles, Python template classes, Pydantic validation, and programmatic optimizers, you can build AI architectures that actually scale. Start treating your prompts as structural code components today, and just watch how much more reliable your AI applications become. Thanks so much for tuning in.